All right, so this is lesson 2 in the trig unit, and this is on trig ratios. Okay, so this is like comparing how big one side of a triangle is compared to another. And there's 3 different ratios that have special names that we're going to talk about. Before we do that, we need to talk about what the names of the different sides of a triangle are. So when we label a triangle, it's based off of what angle we're talking about. I'll show you what I mean here. So there's um, three sides to a triangle. One of them is always going to be the same. We've already talked about this one before. This is called the hypotenuse. So the hypotenuse is always the longest side of a triangle. And no matter where we're looking from, no matter what angle we're talking about, the hypotenuse is going to stay the same. Okay, the hypotenuse is always the longest side, and it's always directly across from the 90-degree angle. So in this triangle here, here's our 90-degree angle. This side we can tell is the longest because we have them all labeled, and it looks like we can kind of visually see that it's the longest. But to be extra sure, if these weren't labeled with numbers, it is directly across from the 90-degree angle. Okay, so it is not touching that 90-degree angle, it is directly across from it. So this one is the hypotenuse, and often the abbreviation of just writing the first 3 letters is how we label them. Rather than writing out the entire word every single time, often for hypotenuse, we'll just write HYP for hypotenuse. Okay, okay next up, we have opposite and adjacent. So whenever we're given a problem like this, we're going to be asked to look from a certain angle as a reference. So these examples say label the following triangles using A as a reference. We're talking about like angle A right here, this angle, and this angle right here. So looking from angle A, we want to know what side is opposite from angle A and what side is adjacent to angle A. So opposite is exactly what it sounds like. It's on the opposite side. It's like it's far from it. It's not touching it. And adjacent is another word for kind of meaning like beside. So adjacent is the side that's right next to the angle that is not the hypotenuse. Okay, so the hypotenuse is right next to our angle A as well, but that is our hypotenuse. It's always going to be the same. The other side here that's next to it is the adjacent. So often we would just write ADJ to stand for adjacent. All right, then lastly, we have the opposite side. So the opposite side is the side across the triangle from the angle. So we're looking from this angle and right across the side that it is not touching. Okay, so this side here is not touching this angle at all. That side is opposite, and we often just write OPP to stand for opposite. Now, notice that if we would have been talking about angle B, that opposite and adjacent would have flipped. Okay, if we were talking about here, well, this is adjacent to B, and this is opposite of B. So it depends on what angle we're talking about. In this next triangle here, we are again looking from angle A as our reference. And so looking from this angle here, we need to determine what our 3 sides are. So the hypotenuse is always the same. The hypotenuse is always that longest side in the triangle that's right across from the 90-degree angle. So here's our 90-degree, and right across from there, this is our hypotenuse. And we can also tell that it's the longest side here. So I'm going to write HYP to stand for hypotenuse. And now we need to determine which is opposite and which is adjacent. So opposite of angle A, directly across the side it's not touching, would be this 12-centimeter side right here. This is opposite. I'm running OPP for opposite. And adjacent, the adjacent side, the side right next to the angle, is this side here. So I'm going to write ADJ to stand for adjacent. Okay. So these we're going to use over and over and over again for the whole rest of the unit. So you'll get very practiced at these. Yeah, make sure that you know what those words mean: hypotenuse, adjacent, and opposite, and then what those first 3 letters mean. That's often what I'll write as a abbreviation. Okay, so that brings us to the trigonometric ratios, okay, which sounds scarier than it is. So there are 3 ratios, which means like comparisons of pairs of sides in a triangle. There's the ratio of how big the opposite side is compared to the hypotenuse. There's the ratio of how big the adjacent side is compared to the hypotenuse. And then there's the ratio of how big the opposite side is compared to the adjacent. So the special names that we have for these are called the sine ratio. So the sine ratio is the opposite and hypotenuse. The cosine ratio is the adjacent and hypotenuse. and the tangent ratio is opposite and adjacent. So there's a easy way to remember this, but this is also in your formula sheet. So if you don't have your formula sheet out, then this is something that I write out at the top of like all my trig problem pages, where on top of like almost every problem, I write out SOHCAHTOA. Okay, so what does this mean? What this means is just a way of remembering all of this information. S stands for sine. Okay. The C in this one stands for cosine, and the T in this one stands for tangent. So this is saying, and then all the other letters are just the sides that we just talked about. So sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Okay, OPP for opposite hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so it's always the trig ratio, so sine, cos, and tan, that's the first letter. The second letter is always the one that goes on top, and the third letter is always the one that goes on the bottom. Okay, so you don't have to have this memorized, but you will likely end up memorizing it by accident by the end of this unit because we'll use it so much. So all this is not going to mean a whole lot to you at this point, and even by the end of the lesson, you still might be wondering why we're doing this. We will use this to good purpose in the next couple lessons, so you have to just trust there. All right, so in this example then, we're not just going to label our sides, we're also going to set up our three ratios. And it says to set them up as both in fraction form and in decimal form. So I'll show you what that means in just a second. So to start off, let's just label our triangle. We're looking from angle A. Okay, it's telling us what we're looking from angle A. So our longest side across from the 90 is our hypotenuse, as always. The side opposite of A is this side 20 here. I'm going to label that opposite. And this one here is adjacent. All right, so now it's time to label our trig ratios, or sorry, to set up our trig ratios. So I'm going to write out my SOHCAHTOA here. All right, so my first one is sine of angle A, and often we just write it in brackets to say that this is like sine of angle A. It's talking about that angle A. These brackets don't really do anything other than just kind of show that it's attached to this sine, is equal to the opposite over the hypotenuse. Okay, so this is the side, this is kind of like the formula before we really filled it in with anything. Okay, so now if we want to say, what is this ratio for this triangle, we need to fill in the opposite side length and the hypotenuse side length. So we're going to say sine of angle A is, our opposite is on top, that's 20. And our hypotenuse is on the bottom, and that is 29. 29. Okay. So this is our trig ratio in fraction form. It's saying like the sine ratio of those two sides is 20 over 29. It also asks for decimal form. That is just turning this fraction into a decimal. So you are just taking your calculator and saying 20 divided by 29. That's it. So 20 divided by 29 is 0.68. Okay. So our sine ratio is equal to 20 over 29. Another way of writing that is 0.68. And we are done our sine ratio. So again, right now, this is not very useful. It will be useful later on. Okay, now let's do our cos ratio. So that was sine. Now we're going to do cos. So cosine from angle A, this little circle here is saying degrees, and is equal to the adjacent side over the hypotenuse. Okay, you don't always need to write out this part of the formula, the adjacent over the hypotenuse. I'm writing it out in words right now, but it is good to write some of this out or have that, be looking at that formula so that you don't get it backwards. Often students will get those upside down, and they'll do everything right. It's just that the numbers they put in will be upside down, and so then they get a slightly wrong answer. All right, so our adjacent side here is 21, and our hypotenuse is 29. This is going to be 21 is our adjacent, over 29 is our hypotenuse. And then we put that into our calculator. 21 divided by 29 is equal to 0.72. 0.72. So this decimal and this fraction mean the same thing. They are both the cos ratio. All right, lastly for this triangle, I'm just going to take up this whole page of space kind of here, is our tangent ratio. So tangent is opposite over adjacent. So we write it out the exact same way that we did the others. Okay, so tan of angle A is equal to, in this case, it's our opposite over adjacent. So TOA is tan is opposite over adjacent. So tan A, now we just fill it in with our numbers. Opposite is 20 and adjacent is 21. So tangent is 20 over 21. And if we put that into our calculator, 20 divided by 21, we get 0.95. 0.95. Now, one warning here is that your calculator can be either in degrees or radian mode. So if you were trying to do this and follow along with me and you were getting different numbers in the end, or sorry, actually in this one, it won't matter, but later on it will, where you need to, on your calculator, go to, for like the TI, the Texas Instruments calculator, there's normally a mode button. So I'm just going to pull that up here quickly. So on your TI calculator, there's normally a button that says mode. So when you press that, you'll see that there's a spot that says radians and degrees. And right now I have degrees highlighted. If your calculator is in radian mode, later on you will start getting wrong answers, even though you're doing everything right. So all you need to do is just go to there, and then you'll push over to get to degree mode, and then you'll press enter, and it will be set up for you. So if it looked like this, then I would be in radian mode, and instead I just push the over to degree mode and hit enter, and now my calculator's in degree mode. So just be careful about that. If ever your calculator gets reset, it will default to radian mode. In this course, we will always use degrees. You don't really need to know about what the difference is, other than because we're talking about our angles being in degrees, that's what we need to use. Okay, so this second triangle is everything's the exact same, it's just different numbers. You're setting up your sine ratio as opposite over hypotenuse. You're setting up your cos ratio as adjacent over hypotenuse, and tangent is opposite over adjacent. It's just filling in those things with different numbers. Okay, so I'm going to just clear the screen and put those answers up, and I'll leave it up for a second, but I'm not going to go through the entire thing step by step. All I'll do is just label right now that we have our hypotenuse right here. Opposite of this side would be this one here, and adjacent would be this 16. Okay, so I'm just going to clear the screen and put those answers on there. And sorry, I just realized that you did not see that. There you go. Hypotenuse is here of this angle, opposite is here, and adjacent is here. So these are all going to be the same idea, just filling with different numbers. All right, so I took out all the old numbers, and we're just going to fill these in with new numbers. So the sine ratio is opposite over hypotenuse. So for this triangle, our opposite is 30, and our hypotenuse is 34. So sine is 30, or sorry, opposite is 30, and hypotenuse is 34. And we put that into our calculator, is 0.98, or sorry, 0.88. Cosine is adjacent over hypotenuse. Our adjacent is 16, and our hypotenuse is 34. So in our calculator, we say 16 divided by 34, and that is the same thing as saying 0.47. And then lastly, our tangent ratio is opposite over adjacent, so it's 30 over 16. Opposite is 30, and on the bottom is our adjacent is 16. Now you'll notice in this one that the top is bigger than the bottom. That happens when we're doing the tangent ratio sometimes. Don't confuse yourself and then switch them. Just because the top is bigger than the bottom doesn't mean that you've done it wrong. Sometimes people switch them just because they think that. So just be careful. That does happen sometimes, and that's okay. Okay, so then lastly, we would say 30 divided by 16, and we would get 1.875. 1.875 is our decimal form of this. Okay, and so that is how we set up our three trig ratios, sine, cos, and tangent, using opposite, adjacent, and hypotenuse for our sides, and our SOHCAHTOA here. Okay, so remember that SOHCAHTOA is on your formula sheet. These three ratios are on your formula sheet. Have these out so that you don't start getting confused. And the answers for this assignment are at the bottom of the page. So you can check your answers with the answer key here as you go. So good luck on the assignment, and see you in the next one.